All right, so today we're going to be talking about scale, which is our new unit that we're working on. It's going to be broken into two videos. The first one's going to be about basically, if you're going with the textbook, 4.1 and 4.2. These are like the basics of scale and how to do it with pictures. The next video we're going to do is going to be a little bit of the harder questions when we're actually doing the complex math using fractions. So let's just start talking about the basics of scale and what it means. Okay, so scale is essentially when you have something. Okay, a shape, a picture, a line, anything. And then you either shrink it or expand it by the same amount to all the parts of the shape. So if I took this square and then I wanted to make it twice as big, so I made it, each side would be twice as big. Okay, this new square would be drawn to scale. If I instead only made one of the sides twice as big, so I made like the top twice as long, but the side was the same, this wouldn't be to scale. One side would be shifted, but the other one wouldn't. So this is a completely different shape. So the idea of drawing something to scale means that even though it looks bigger, it still has the same overall shape. We'll understand more what that means, but it's basically there's a connection between what the sides are. But a way of thinking of it is when I do this in the video, see this square right here? It's this big. When I zoom in on the video like that, it is still to scale. It's bigger, but all the sides are still in the same proportion to each other. Same thing as if I zoom out, again, that square stayed the same, it just got shrunk. Okay? So when we're dealing with scale, it either means to expand or to shrink. We usually call scale using a factor or a ratio like this. The first number, the 1, represents the original shape you had. Okay? It means it's 1 times the size. It's how big it normally is. The way that you say this colon, you pronounce it as 2. So this would be read as 1, 2, 3. The scale of 1 to 3. The second number, this, represents the new shape that we have over here. Okay? And how big it is. So in this case, actually, we said it was multiplied by 2, so the scale would be 1 to 2. This rectangle represents a scale of 1 to 2 from the original to the new size. So now that we know what this scale means, we can apply it to some situations. So for example, if I let's draw another rectangle. I'm going to make up some measurements, 3 centimeters, 1 centimeter. If we're going to draw a new rectangle, and we have to use this scale of 1 to 4. Okay? I'm going to sketch it really fast. It's going to be wrong. But let's write how long the sides would be. So what we're going to do is we have to find which sides match. So this side right here matches up with this side right here. I'm going to take that 3 centimeters and then I'm going to multiply it by whatever my scale is. So in this case it was 4. So times 4 is going to become 12 centimeters. Then I'm going to take the other side here, find the side it matches with, and I'm going to multiply it by my scale factor again of 4 to give me 4 centimeters. So that means if I had to draw it 4 times as big, this is what it would look like. Or at least this is how long the side would be. There's other scales we can do which look like this. Okay? When you have a scale factor where there's a decimal or a number smaller than 1, it's actually going to shrink. And this makes sense because anything bigger means we're multiplying by 4, 5, 10. It's getting that many times bigger. If we multiply by 0.5, the numbers are going to turn smaller, which means we're going to get a shrunken version. So for example, again, let's draw a shape. Say this is 2 centimeters and this is 5 centimeters. If I'm going to use this scale, I'm going to redraw it. But again, I have to match up the sides. This 2 turns to this. And I'm going to multiply it by whatever my scale is. In this case, 0.5. So it's going to become 1 centimeter. Then I'm going to take this side. It matches up with this side over here. And I'm going to multiply it just like we did before by 0.5. So this is going to turn into 2.5 centimeters. These two numbers together, we're not going to multiply them together, anything like that. That's not how it works. Okay? We find which side matches, and we use the scale factor to change it. Now the last thing we have to be able to do is figure out a scale when we're given some pictures. So let's draw another one. This time I'm going to draw like a smiley face. Okay? So let's say that this original smiley face had a scale of, let's say the width was, 10 centimeters. Okay? And then this new, bigger smiley face has a width of 30 centimeters. We have to figure out what's the scale, what's the number here that shows how we multiplied to get to the other one. So now, you might be able to do this in your head and know it's just 3, but when we have harder numbers with decimals, we need to figure out a way to do this. So the pattern is, we take these two numbers, because they match up with each other, okay? And we're going to write a ratio, or a fraction. We're going to take the new and divide it by the old. So in this case, the new represents the new shape, the bigger one. It can be smaller, but it's whatever the new one is. The old represents the original shape, what we had to start with. Okay, so let's erase that. I'm going to take these numbers and put them in my equation. 30 was the size of the new, old was 10. When we do the math, we get 3. And then we can double check to make sure, because if you ever actually mix these up, it can be easy to fix, because that would have given us an answer of 0.333. Okay? When we think of our scale, if I had written 0.333, in my head I know that means it's getting smaller, which doesn't make any sense, so that would have been wrong. The answer of 1 to 3 does make sense because I went from this and it got bigger. Yep, that's the basics that we need to know how to do. There are a little bit trickier questions, so they might give you something like this, and they say this is an unknown, and you know that this is, I don't know, 12. I guess it wouldn't be 12. Say like 25. Okay, and you would need to find out how big this is. I'm going to show you how to do that in the next video using like a better system. But the basics understanding is, you need to know if you get a scale, something like this, you need to understand how to read it, what it means, and you need to understand if you have some numbers for the sides, how to calculate new sides. And that's it.